Something ancient is stirring under your feet, not in the oceans, not in the skies, but deep, so deep it brushes the edge of Earth's core. A colossal churning engine of heat and pressure is slowly forcing its way upward. It's not a myth. It's not science fiction. It's real, it's happening now, and it's reshaping the future of an entire continent. Welcome to the East African Rift System, ground zero for one of the most dramatic tectonic transformations our planet has seen in millions of years. On May the 12th, 2025, a team of researchers led by geochemist Biying Chen at the University of Edinburgh published groundbreaking findings in the journal Geophysical Research Letters. Their discovery confirms what scientists have long suspected but could never prove. A massive superplume, a rising column of hot rock originating near the Earth's core, is tearing Africa in two. This isn't just another crack in the Earth's crust. This is a deep mantle event stretching across thousands of kilometers. From the Red Sea in the northeast to Mozambique in the south, the African continent is slowly but unrelentingly splitting apart. And the culprit isn't just surface-level tectonics. It's coming from nearly 1,800 miles or 2,900 kilometers below. The team focused their attention on the Mengai geothermal field in central Kenya, one of the many volcanic hot zones dotting the East African Rift. By analyzing neon isotopes trapped in volcanic gases, they detected a distinct geochemical fingerprint, one that could only come from the deep mantle, a place untouched by surface processes since Earth first formed. It's a signature so rare and so ancient, it's only been seen in a few places on Earth, most notably Hawaii. That's right. The same kind of primordial mantle material fueling the Hawaiian hotspot is also rising beneath Africa. But unlike the narrow, focused plume beneath Hawaii, often likened to a column in a lava lamp, the superplume beneath Africa appears to be a vast, amorphous mass. A wave of hot, buoyant rock pushing upward and spreading laterally, bulldozing the brittle lithosphere above it. This upwelling, now confirmed through precise neon isotope analysis, is what's fueling the extreme volcanic activity across the East African Rift System. EARS, the largest active continental rift on Earth. At over 2,975 miles, or about 3,500 kilometers long, the EARS is reshaping the geography of the continent, creating rift valleys, volcanic chains, and even new microplates. The continent has been cracking apart for around 35 million years, but the real story starts far deeper, at the core mantle boundary, where Earth's solid iron heart meets its molten outer shell. From this infernal border, a plume of extraordinary heat and pressure has been rising steadily, invisibly, for tens of millions of years. Until now, geologists could only theorize its existence. Chen's team deployed some of the most sensitive geochemical tools ever used on-site in Kenya. They zeroed in on noble gases, especially neon. These inert elements are geological time capsules. Because they don't react easily with other substances, they preserve the conditions of their origin. What they found was remarkable. A neon isotope ratio almost identical to the ancient mantle signatures detected in Hawaiian rocks. We were very excited to see the preliminary isotope data showing the primordial deep mantle signature, Chen told Live Science. But the deep mantle signature is small, and we had to work hard to disentangle it. Truthfully, there was no eureka moment. We frequently questioned the result and spent many hours checking and rechecking the data. That dedication paid off. The same deep mantle signature found in central Kenya also appears in volcanic rocks as far north as the Red Sea and as far south as Malawi. This strongly suggests a single, continent-wide plume is rising beneath the entirety of the rift system, uniting these far-flung regions through a common geological thread. And it doesn't stop there. The spread of this upwelling superplume is powerful enough to fracture the lithosphere, the rigid outer shell of our planet. As the hot rock rises, it spreads out against the cooler, more brittle crust above. That spreading builds pressure. And pressure, as geologists know all too well, leads to fracture. The result? Cracks, valleys, volcanoes, lakes where none once existed. And over the long term, a new ocean. Geologists predict that in 5 to 10 million years, the East African Rift will evolve into a full-fledged, divergent plate boundary. The Horn of Africa will break away, forming a new continent. The Red Sea and the Gulf of Aden will expand, flooding the rift zone and birthing a new ocean basin. Think about that. Future civilizations, if they exist, will see an entirely new map of Earth. Somalia and parts of Ethiopia, Eritrea, Djibouti, and Kenya may become part of a separate tectonic plate, adrift in the Indian Ocean. The signs of this continental breakup are already here. In 2018, a massive crack opened in Kenya's Narok County, stretching nearly 15 meters wide and several kilometers long. It shocked locals, but to geologists, it was a visible symptom of the deeper forces at play. Satellite imagery has since revealed dozens of such stress points forming and shifting across the region. Earthquakes and volcanic eruptions are becoming more frequent along the rift, from Ethiopia's Afar Triangle to the Nyiragongo volcano in the Democratic Republic of Congo. Volcanism in ears isn't just destructive, it's uniquely intense. Lava here often bubbles from rift zones at lower temperatures than other hotspots, likely due to the mantle's unusually high volatile content, another indicator of deep origin. These volatiles include water, carbon dioxide, and sulfur, all carried upward by the superplume. This rising heat is also a double-edged sword. On one hand, it powers geothermal energy, already being tapped in Kenya, Ethiopia, and Tanzania. On the other, it destabilizes the crust, increases seismic risk, and creates complex challenges for regional planning, agriculture, and infrastructure. There's more at stake than just geology. The East African Rift System passes through one of the most densely populated regions on the continent. Cities like Nairobi, Addis Ababa, Kigali, and Goma lie along or near the rift. Millions of people live on a literal fault line. Understanding the dynamics of this superplume is vital, not only for predicting future eruptions, but also for developing early warning systems and sustainable development strategies. It's also sparking a rethinking of how continents evolve. Traditionally, scientists viewed rifts like ears as driven primarily by plate tectonic forces, pulling the crust apart due to movements in the surrounding plates. But this study strengthens a more profound idea, that heat from Earth's core can actively fracture the surface from below. It's not just the plates moving on top of a passive mantle. The mantle itself may be far more dynamic, shaping continents, splitting landmasses, and fueling planetary evolution. And there's an even broader mystery that looms beyond Earth. If we better understand superplumes here, we might uncover how alien worlds evolve. The Martian Tharsis region, Venus's massive rift zones, even mysterious cryovolcanoes on icy moons like Enceladus. Each may be driven by their own versions of internal plumes. Earth's story may be the Rosetta Stone of planetary geology. Biying Chen's work, and the work of countless geologists before her, has brought us closer than ever to understanding the invisible forces that sculpt continents. And in doing so, it reminds us just how alive our planet really is. So, the next time you look at a map of Africa, imagine not just the surface, but the vast boiling cauldron underneath, a force older than civilization, deeper than any ocean, and powerful enough to one day split a continent in two. This isn't the plot of a disaster movie. It's Earth in action, and it's happening now. To stay updated on the hidden forces shaping our planet, and to explore the science that will define our future, make sure you subscribe and join us for the next discovery. Because beneath the surface lies everything.